Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper, Math P4, Variant 3, May-June 2018. Let's get started. Rowena buys and sells clothes. She buys a jacket for $40 and sells it for $45.40. Calculate the percentage profit. The percentage profit is equal to the profit, which is $45.40 minus $40 divided by the cost of getting the jacket, which is $40 times 100%. This gives us 13.5%. She sells a dress for $42.60 after making a profit of 20% on the cost price. Calculate the cost price. Since she made a profit of 20% selling the dress, then the selling price, which is $42.60, is 120% of the cost price. When we make the cost price the subject, this is what we get, which is equal to $35.50. Sarah invests $500 for 15 years at a rate of 2% per year simple interest. Calculate the total interest Sarah receives. Here is the formula for calculating the total interest. The principal P in this case is $500. The annual rate R is 2% and the time T is 15 years. When we type this into the calculator, we get $150. Thomas has 2 cars. The value today of one car is $21,000. The value of this car decreases exponentially by 18% each year. Calculate the value of this car after 5 years. Give your answer correct to the nearest $100. In this case, we need to apply the compound or exponential formula. Since we are dealing with a decrease, we bring a minus here. Big A represents the final value of the car, which is what we want to find. Small a represents the current value of the car, which has been given as $21,000. The annual rate R is 18% and the time duration T is 5 years. When we type this into the calculator, this is what we have. The number in the hundreds position is 7. The number after 7, which is 8, is greater than 5. So we add 1 to 7, giving us 8. The numbers after 7 become 0, so we have $7,800 rounded to the nearest 100. The value today of the other car is $15,000. The value of this car increases exponentially by X% each year. After 12 years, the value of the car will be $42,190. Calculate the value of X. In this case, we also need to apply the exponential formula. Since we are dealing with an increase, we bring a plus here. The annual rate has been given as X%, which we've been asked to find. So when we make X the subject, this is what we have. Big A represents the final value of the car, which is $42,190. Small a represents the current value of the car, which is $15,000. The time duration T is 12. When we type this into the calculator, we get 9.00 rounded to 3 significant figures. Y equals 2 raised to the power x. Complete the table. When we plug in x equals 0 into the equation, we get y equals 1. For x equals 4, we get y equals 16. Y equals 14 minus x squared. Complete the table. When we plug in x equals 0 into the equation, we get y equals 14. For x equals 4, we get y equals -2. On the grid, draw the graphs of y equals 2 raised to the power x and y equals 14 minus x squared. For x is greater than and equal to 0 and less than and equal to 4. For the graph of y equals 2 raised to the power x, we plot all the points in table AI and connect the points with a smooth line. For the graph of y equals 14 minus x squared, we plot all the points in table AII and connect the points with a smooth line. Use your graphs to solve the equations. 2 raised to the power x equals 12. To solve this equation using the graph, we need to find the x-coordinate of the intersection point between the curve y equals 2 raised to the power x and the line y equals 12. On the grid, we've drawn the line y equals 12 and the x-coordinate of the intersection point with the curve is 3.55. Use your graph to solve the equation 2 raised to the power x equals 14 minus x squared. To solve this equation using the graph, we need to find the x-coordinate of the intersection between the curve y equals 2 raised to the power x and the second curve y equals 14 minus x squared. On the grid, we see that the x-coordinate of the intersection point is 2.75. On the grid, draw the line from the point 4, 2 that has a gradient of -4. To be able to draw a straight line, we need to have at least 2 points on the line. We've been given the gradient and one set of the coordinates of the line. We can use this to find the second set of coordinates. By applying the gradient formula, we get the second set of coordinates to be 3, 6. So on the grid, we plot these 2 points and draw a straight line through the points. Complete the statement. This straight line is a blank to the graph of y equals 14 minus x squared at the point blank. On the grid, we see that the straight line touches the curve y equals 14 minus x squared at the point 210. So we say the straight line is a tangent to the curve at the point 210. The scatter diagram shows the physics mark and the chemistry mark for each of 12 students. What type of correlation is shown in the scatter diagram? On the scatter diagram, we see that as the physics marks for the students increase, there is a general increase in their chemistry marks. This type of correlation is positive. On the scatter diagram, draw a line of best fit. On the diagram, we've drawn a line of best fit. The general rule of thumb for drawing a line of best fit is to ensure that it passes through as many points as possible while balancing an equal number of points above and below the line. Find an estimate of the chemistry mark for another student who has a physics mark of 4. When we map 4 from the horizontal axis, we get the estimated chemistry mark to be 1.7. A teacher records the number of days each of the 24 students in her class are absent. The frequency table shows the results. Find the mode, the median, and the mean. The mode is the most recurring number or the number with the highest frequency. The highest frequency is 10 and the number with this frequency is 0. The median is simply the middle number. To get the position of the median, we use the formula half n plus 1, where n in this case is 24. This gives us 12.5. This means the median is between the 12th and 13th number. The number of zeros are 10. The number of ones are 8. 10 plus 8 is 18. This means the 12th number is 1 and the 13th number is also 1. And so the median is 1. The mean is equal to the total number of days, which is 0 times 10 plus 1 times 8 plus 2 times 3 plus 3 times 2 plus 4 times 0 plus 5 times 1 divided by 24. When we type this into the calculator, we get 1.04. 3 sizes of eggs are sold in a shop. The table shows the number of eggs of each size sold in one day. Calculate an estimate of the mean mass. The mean is equal to the total mass of all the eggs divided by the total number of eggs. Before we get the total mass of the eggs, we need to get a midpoint mass for each of the given mass intervals. So for the first interval, the midpoint mass is 46 plus 52 divided by 2, which is 49. Then we have 52 plus 62 divided by 2, which is 57. Then finally, 62 plus 80 divided by 2, which is 71. So for the total mass of the eggs, we have 49 times 78 plus 57 times 180 plus 71 times 162 grams divided by the number of eggs, which is 78 plus 180 plus 162. When we type this into the calculator, we get 60.9 grams rounded to 3 significant figures. On the grid, draw a histogram to show the information in the table. To be able to draw the histogram, we need to calculate the frequency density for each of the given intervals. The frequency density is equal to the frequency divided by the interval width. For the first interval, the frequency density is equal to the frequency, which is 78, divided by the interval width, which is 52 minus 46, which is equal to 13. Then we have 180 divided by 62 minus 52, which is equal to 18. Then finally, 162 divided by 80 minus 62, which is equal to 9. So now, after marking all the different intervals on the horizontal axis of the grid, we can map out their heights using their frequency density values. The diagram shows 2 sets of cards. Jojo chooses 2 cards at random from set A without replacements. Find the probability that the 2 cards have the same number. There are 2 possible scenarios in this case. Jojo either picks 2 cards from set A with a 1 or picks 2 cards from set A with a 2. The probability that the first card picked is a 1 is equal to the number of cards with a 1 in set A, which is 2, divided by the total number of cards, which is 5. Without replacements, the pool reduces by 1. So the probability that the second card picked is also a 1 will now be 1 over 4. The probability that the first card picked is a 2 is equal to the number of cards with a 2 in set A, which is 3, divided by the total number of cards, which is 5. Without replacements, the pool reduces by 1, and so the probability that the second card picked is also a 2 will now be 2 over 4. When we type this into the calculator, we get 0.4. Jojo replaces the 2 cards. Kylie then chooses 1 card at random from set A and 1 card at random from set B. Find the probability that the 2 cards have the same number. There are 2 possible scenarios in this case. Kylie either picks 2 cards with a 1 from both sets or picks a card with a 2 from both sets. The probability that the card she picked from set A is a 1 is equal to the number of cards with a 1 in set A, which is 2, divided by the total number of cards, which is 5. The probability that the card she also picked from set B is a 1 is equal to the number of cards with a 1 in set B, which is 3, divided by the total number of cards, which is 5. The probability that the card she picked from set A is a 2 is equal to the number of cards with a 2 in set A, which is 3, divided by the total number of cards, which is 5. The probability that the card she also picked from set B is a 2 is equal to the number of cards with a 2 in set B, which is 1, divided by the total number of cards, which is 5. When we type this into the calculator, we get 0.36. Who is most likely to choose 2 cards that have the same number? Show all your working. The probability that Jojo chooses two cards with the same number, which is 0.4, is greater than the probability that Kylie chooses two cards with the same number. This simply means Jojo is more likely to choose two cards with the same number. Leonard chooses 3 cards at random from set C without replacements. Find the probability that the third card chosen is numbered 4. There are 3 possible scenarios in this case. In the first scenario, she picks 5 the first time, picks 5 the second time, and picks 4 the third time. In the second scenario, she picks 5 the first time, picks 4 the second time, and picks 4 the third time. In the third scenario, she picks 4 the first time, picks 5 the second time, and picks 4 the third time. The probability of picking a card with 5 first is equal to the number of cards with a 5, which is 3, divided by the total number of cards, which is 5. Without replacement, the pool reduces by 1, so the probability that the second card is also a 5 is 2 over 4. Without replacement, the probability that the third card is a 4 is 2 over 3. The probability of picking a 5 first is 3 over 5. Without replacements, the probability that the second card is a 4 is 2 over 4. Without replacements, the probability that the third card is also a 4 is 1 over 3. The probability of picking a 4 first is 2 over 5. Without replacements, the probability that the second card is a 5 is 3 over 4. Without replacements, the probability that the third card is a 4 is 1 over 3. When we type this into the calculator, we get 0.4. At a football match, the price of an adult ticket is X dollars and the price of a child ticket is X minus $2.50. There are 18,500 adults and 2,400 children attending the football match. The total amount paid for the tickets is $320,040. Find the price of an adult ticket. The total amount paid, which is $320,040, is equal to the amount paid by the adults, which is 18,500 times X, plus the amount paid by the children, which is 2,400 times X minus 2.50. When we expand the brackets, 2,400 times X is 2,400X. 2,400 times negative 2.50 is negative 6,000. When we group like terms, this is what we have. When we divide both sides by 20,900, we get X equals 15.60. X dollars is the price of an adult ticket, so we have $15.60. Factorize y squared plus 5y minus 84. We can rewrite 5y as minus 7y plus 12y. When we factor out y from the first two terms, we are left with y minus 7. And when we factor out 12 from the final two terms, we are left with y minus 7. This can be rewritten as y plus 12 times y minus 7. The area of the rectangle is 84 centimeters squared. Find the perimeter. Here is the formula for the perimeter of a rectangle. To be able to get the values for L and W, we first need to find the value of y. We've been given the area of the rectangle. Here is the formula for the area of a rectangle. The area has been given as 84 centimeters squared. The length L is y plus 5 centimeters and the width W is y centimeters. When we expand the brackets, y times y is y squared, y times 5 is 5y. When we move all the terms to one side of the equation, we get y squared plus 5y minus 84 equals 0. In the previous question, when we factorized y squared plus 5y minus 84, we got y plus 12 times y minus 7. When we equate y plus 12 to 0, we get y equals negative 12. And when we equate y minus 7 to 0, we get y equals 7. The width y centimeters cannot be negative, so y is 7 centimeters. And the length is 7 plus 5 centimeters, which is equal to 12 centimeters. So now the perimeter of the rectangle is equal to 2 times 12 centimeters plus 2 times 7 centimeters, which is equal to 38 centimeters. In a shop, the price of a monthly magazine is $M and the price of a weekly magazine is M minus $0.75. One day, the shop receives $168 from selling monthly magazines, $207 from selling weekly magazines. The total number of these magazines sold during this day is 100. Show that 50m squared minus 225m plus 63 equals 0. We are told the number of the magazines sold on the given day is 100. This simply means the number of monthly magazines sold plus the number of weekly magazines sold is 100. To get the number of monthly magazines sold, we divide the amount the shop receives from selling the monthly magazines, which is $168, by the unit cost of a monthly magazine, which is $M. For the number of weekly magazines sold, we divide the amount the shop receives from selling the weekly magazines, which is $207, by the unit cost of a weekly magazine, which is M minus $0.75. To clear the denominators, we multiply through the equation by the LCM, which is M times M minus 0.75, and this is what we get. When we expand the brackets, 168 times M is 168M. 168 times negative 0.75 is negative 126. 100m times m is 100m squared. 100m times negative 0.75 is negative 75m. When we move all the terms to one side of the equation and group like terms, this is what we have. The terms have a common factor of 2. When we divide through the equation by 2, we get 50m squared minus 225m plus 63 equals 0. Find the price of a monthly magazine. Show all your working. We know the price of the monthly magazine is $M, so we need to find the value of M. We get the value of M by solving this equation from the previous question. To solve this equation, we apply the quadratic formula and this is what we get. Negative of negative 225 is 225. The numbers under the square root, negative 225 squared minus 4 times 50 times 63 is 38,025. And for the denominator, 2 times 50 is 100. For the first possible value of M, we get 4.2. And for the second possible value of M, we get 0.3. Out of the two M values, the price of the monthly magazine is $4.2. It cannot be $0.30 because this makes the price of the weekly magazine negative, and prices cannot be negative. In the pentagon ABCDE, angle ACB equals angle AED equals 90 degrees. Triangle ACD is equilateral with side length 12 centimeters. DE equals BC equals 6 centimeters. Calculate angle BAE. Angle BAE is equal to angle BAC plus angle CAD plus angle DAE. Triangle ACD is an equilateral triangle, so angle CAD is 60 degrees. To get angle BAC, we apply SOHCAHTOA to triangle ABC. This gives us tan of angle BAC equals 6 centimeters over 12 centimeters. When we make angle BAC the subject, we get tan inverse of 6 over 12. To get angle DAE, we apply SOHCAHTOA to triangle ADE. This gives us sine of angle DAE equals 6 centimeters over 12 centimeters. When we make angle DAE the subject, we get sine inverse of 6 over 12. When we plug in all these values into the original equation, This is what we have. When we type this into the calculator, we get 116.6 degrees rounded to one decimal place. Calculate AB. To get AB, we apply the Pythagoras theorem to triangle ABC. This gives us AB squared equals AC squared plus BC squared. AC is 12 centimeters and BC is 6 centimeters. When we plug in these values into the equation and make AB the subject, this is what we have, which is equal to 13.4 centimeters rounded to 3 significant figures. Calculate AE. To get AE, we apply the Pythagoras theorem to triangle ADE. This gives us AD squared equals AE squared plus ED squared. AD is 12 centimeters and ED is 6 centimeters. When we plug in these values into the equation and make AE the subject, this is what we get, which is equal to 10.4 centimeters rounded to 3 significant figures. Calculate the area of the pentagon. The area of the pentagon is equal to the area of triangle ABC plus the area of triangle ACD plus the area of triangle ADE. We can find the area of triangle ABC using half base times height, where the base is 6 centimeters and the height is 12 centimeters. We can find the area of triangle ACD using half AB sine C, where A and B can be any two sides of the triangle, with angle C being the angle between the two sides. So we have half of 12 times 12 times sine 60 degrees. We can also find the area of triangle ADE using half base times height, where the base is 6 centimeters and the height is 10.4 centimeters. When we type this into the calculator, we get 130 centimeters squared, rounded to 3 significant figures. The diagram shows a cuboid. AB is 8 centimeters, BC is 4 centimeters, and CR is 5 centimeters. Write down the number of planes of symmetry of this cuboid. Rectangular cuboids have 3 planes of symmetry. Calculate the angle between the diagonal AR and the plane BCRQ. On the diagram, we've labeled this angle as alpha. To get alpha, we apply SOHCAHTOA to triangle ABR. This gives us tan of alpha equals 8 centimeters over BR. When we make alpha the subject, we have alpha equals tan inverse of 8 centimeters over BR. We need to find BR. We can get BR by applying the Pythagoras theorem to triangle BCR. This gives us BR squared equals BC squared plus CR squared. BC is 4 centimeters and CR is 5 centimeters. When we plug in these values into the equation and make BR the subject, this is what we get, which is equal to square root of 41 centimeters. Now that we have BR, alpha is equal to tan inverse of 8 over square root of 41. When we type this into the calculator, we get 51.3 degrees rounded to one decimal place. Water flows through a cylinder pipe at a speed of 8 centimeters per second. The radius of the circular cross-section is 1.5 centimeters and the pipe is always completely full of water. Calculate the amount of water that flows through the pipe in 1 hour. Give your answer in liters. The amount of water or volume of water that flows through the pipe can be found using this formula. We can find the volume flow rate through the pipe by multiplying the cross-sectional area of the pipe by the linear flow rate or the speed of the water through the pipe. The cross-sectional area of the pipe can be found using pi r squared, where the radius r of the pipe is 1.5 centimeters. We've been given the linear flow rate as 8 centimeters per second. T in this case is 1 hour, which we multiply by 3600 to convert it to seconds. When we type this into the calculator, we get 64,800 pi centimeters cubed. We need to give our answer in liters. So to convert to liters, we multiply this by 10 raised to the power negative 3. When we type this into the calculator, we get 204 liters rounded to 3 significant figures. The diagram shows 3 solids. The base radius of the cone is 6 centimeters and the slant height is 12 centimeters. The radius of the sphere is x centimeters and the radius of the hemisphere is y centimeters. The total surface area of each solid is the same. Show that the total surface area of the cone is 108 pi centimeters squared. The total surface area of the solid cone is equal to the area of its curved surface plus the area of its circular base. The area of the curved surface can be found using pi RL, where the radius r in this case is 6 centimeters and the slant height L is 12 centimeters. The area of the circular base can be found using pi r squared, where the radius r is 6 centimeters. Pi times 6 times 12 gives us 72 pi, and pi times 6 squared gives us 36 pi. 72 pi plus 36 pi is 108 pi. Find the value of x and the value of y. We are told the total surface area of all the solids is the same. This means the surface area of the cone is the same as the surface area of the sphere, and the surface area of the cone is also the same as the surface area of the hemisphere. We know the surface area of the cone is 108 pi, and the surface area of the sphere can be found using 4 pi r squared, where the radius r in this case is x centimeters. From here, we can find the value of x. When we divide both sides by 4 pi, this is what we get. When we take square root of both sides, this is what we have, which is equal to 5.20, rounded to 3 significant figures. Now let's find the value of y. The surface area of the cone is 108 pi. The surface area of the solid hemisphere is equal to the area of its curved surface, which is 2 pi r squared, where r in this case is y centimeters, plus the area of its circular top, which is pi r squared, where r is y centimeters. 2 pi y squared plus pi y squared is 3 pi y squared. When we divide both sides by 3 pi, we get y squared equals 36. And when we take square root of both sides, we get y equals 6. For the following calculations, put a tick if it's possible or put a cross if it is not possible. There is no need to carry out any of the calculations. N is a 1 by 2 matrix and P is a 2 by 1 matrix. The two matrices need to have the exact same order if they are to be added. For example, both need to be of the order 1 by 2, which does not apply in this case, and so the calculation is not possible. In this case, we are multiplying a 1 by 2 and a 2 by 1 matrix. Since these two inner values are equal, then it means the calculation is possible. In this case, we are multiplying two 2 by 2 matrices. Since these two inner values are equal, then it means the calculation is possible. Here, we are multiplying two 1 by 2 matrices. Since these two inner values are not equal, then it means the calculation is not possible. For this, we are multiplying a 2 by 2 matrix and a 1 by 2 matrix. Since these two inner values are not equal, then it means the calculation is not possible. In this case, we are multiplying a 1 by 2 matrix and a 2 by 2 matrix. Since these two inner values are equal, then it means the calculation is possible. Work out 1, 2 plus P. We've been given P as 4, 1. So to get the resulting vector, we add corresponding elements in both vectors. So 1 plus 4 is 5 and 2 plus 1 is 3. So we have 5, 3. Work out Pn. For this, we are multiplying a 2 by 1 matrix and a 1 by 2 matrix. Since the inner values are equal, it means the calculation is possible and the resulting matrix would be 2 by 2. To get the elements in this position, we multiply the elements of row 1 of the first matrix and column 1 of the second matrix. So we have 4 times 1, which is equal to 4. For the elements in this position, we multiply the elements of row 2 of the first matrix and column 1 of the second matrix. So we have 1 times 1, which is equal to 1. For the elements in this position, we multiply the elements of row 1 of the first matrix and column 2 of the second matrix. So we have 4 times 2, which is equal to 8. Then for the elements in this position, we multiply the elements of row 2 of the first matrix and column 2 of the second matrix. So we have 1 times 2, which is equal to 2. Work out the inverse of matrix M. We've been given the matrix M as 2, 4, 1, 3. To get the inverse of the matrix, we have 1 over the determinant of the matrix, which we get by subtracting the product of the minor diagonal, which is 1 times 4, from the product of the major diagonal, which is 2 times 3. Then we multiply by this matrix, which we get by swapping the elements in the major diagonal and negating the elements in the minor diagonal. 2 times 3 minus 1 times 4 gives us 2. So we have 1 over 2 times 3 negative 4, negative 1, 2. Describe fully the single transformation represented by the matrix 0, 1, negative 1, 0. The given matrix represents the transformation rotation 90 degrees anticlockwise about the origin. Find the equation of the straight line that is perpendicular to the line y equals half x plus 1 and passes through the points 1, 3. All we need to do is find the values of m and c of the perpendicular line and plug in these values into y equals mx plus c. We are told the line is perpendicular to y equals half x plus 1. This line is already expressed in the form y equals mx plus c, and so the coefficient of the x term, which is half, is the gradient of the line. Since the lines are perpendicular, we know that the product of their gradients must be equal to negative 1. This gives us the gradient of the line to be negative 2. To get the value of c, we plug in the value of m and the coordinates through which the line passes into y equals mx plus c. This gives us 3 equals negative 2 times 1 plus c. Negative 2 times 1 is negative 2. When we add 2 to both sides, we get c equals 5. So we have y equals negative 2x plus 5. Find the 3 inequalities that define the region R. First, we need to find the equations of the lines or boundaries of the region R. So we have x equals 2, y equals 5, and y equals half x. The region R is to the right or above x equals 2. So we define this region as x is greater than and equal to 2. R is below y equals 5, so we define this region as y is less than and equal to 5. R is above y equals half x, so we define this region as y is greater than and equal to half x. We need to attach an equal sign to all the inequality symbols because the boundaries have been drawn with a solid line. Find the point xy with integer coordinates inside the region R such that 3x plus 5y equals 35. This point has coordinates 5, 4. 3 times 5 plus 5 times 4 gives us 35. Find g of 2. First, let's find g of 2. To get g of 2, we replace x in g of x with 2. This gives us 2 squared plus 1, which is equal to 5. So now to get g of 2, we replace x in g of x with g of 2, which we found to be 5. So we have 5 squared plus 1, which is equal to 26. Find g of x plus 2, given your answer in its simplest form. To get g of x plus 2, we replace x in g of x with x plus 2. This gives us x plus 2 squared plus 1. When we expand x plus 2 squared, we get x squared plus 4x plus 4. 4 plus 1 is 5, so we have x squared plus 4x plus 5. Find x when f of x equals 7. F of x, which is 2x minus 3, is equal to 7. When we add 3 to both sides, we get 2x equals 10. And when we divide both sides by 2, we get x equals 5. Find f inverse of x. We've been given f of x as 2x minus 3. So first, we replace f of x with x and replace x with y. When we make y the subject, this is what we have. The expression we have for y is the same as f inverse of x. So f inverse of x is also equal to x plus 3 over 2. H of x equals x raised to the power x, where x is greater than 0. Calculate h of 0.3. Give your answer correct to 2 decimal places. To get h of 0.3, we replace x in h of x with 0.3. This gives us 0.3 raised to the power 0.3. When we type this into the calculator, we get 0.70 rounded to 2 decimal places. Find x when h of x equals 256. H of x, which is x raised to the power x, is equal to 256. X cannot be 0 in this case, and we know that 4 raised to the power 4 gives us 256. So x is 4. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.